So now we're going to work with chapter 12. Chapter 12 is a really interesting chapter because the two sections that we do in it are all dealing with categorical or qualitative data, which is interesting because we really haven't dealt with qualitative data for quite some time. Not really since chapter 5, to be honest. Okay, so the first test we're going to learn is something called a goodness of fit test, in which you're trying to determine whether the proportions that you see follow a specific distribution. For example, M&Ms come in different colors. The company claims on its website that these are the percentages that they produce. 13% in a bag are brown, 40% are yellow, and so on. Of course, it'd be for a bag of plain M&Ms. But is this accurate? So that's what they claim. That's what we expect. But then you tear open a bag and you observe what you actually see, right? And so your null hypothesis is that the proportions of brown, yellow, and red are what they claimed it was. And then the alternative to that would be that something is different, right? That we're not seeing what we would expect. We'll work on that in a second. So the next one, and you can see I've actually filled in the null hypothesis for some of these. So the next one, you think an 8-sided die is fair and expect that each side should roll 1/8 at a time. But will it really? So we roll it, we take that die, we roll it 1,000 times, and we observe the actual numbers that we rolled. And then we compare the two. So the null hypothesis would be that it's fair, which would mean every side, 1 through 8, would happen 1/8 of the time. That's the null hypothesis. Okay, so what about the next one? Republican voters have to vote for a candidate in the primary for the U.S. presidency. Based on polling, we expect that Rick Perry will get 32% of the Republican vote, Mitt Romney will get 41% of the vote, and Ron Paul will get 16% of the vote, and so on. But does what we observe on Election Day match what we expected? So I could write this a whole bunch of ways. Let me go in here and just say the proportion that votes for Rick. Oops. There we go. You know what? Let me write this up. I'll be right back. There we go. That's better. Okay, so the proportion that vote for Rick Perry is 32. The proportion that votes for Mitt Romney is 41. And the proportion that votes for Ron Paul is 16. And then, of course, the alternative that would be that at least one of these is different, right? Not what we expected. Okay, so that's the null hypothesis. You assume that what you polled was actually going to happen. Medical research body believes that in childbirth, 1% of births will result in stillbirth, 14% will result in complications for the baby that require neonatal care, 21% of the births will result in complications for the baby that do not require extra care, and the rest will be fine. But does the local hospital have statistics that match those results? Okay, so let me write that up. So the proportion that would need stillbirth would be 1%. Or you could say 0.01, either way. All right, let me type the rest of this up. I'll be right back. There we go. So I have written up all these percentages. And notice, because I know that the whole thing makes 1, because you have to have 100%, that I know the just fine, the rest will be fine right here, has got to account for 64%, because that way it adds up all the way to 100%. I mean, if I want to do the same thing here, I could have said, oopsie, let me make it wider so you can see. There's a proportion for other. Who knows? It'll be all the other candidates combined, right? Which would make, let's see, that's 73, 83, 89, so it'd be 0.11. Cool. All right, so now we need to get into expectation. So what we expect to happen is these percentages to be followed, and a lot of times they'll work out evenly. And then you need to be able to figure out how many that is. So for example, there are 12 astrological signs that divide up the calendar equally. It's 12 months, right? If you're going to look at a distribution of 1,067 people, compute the number you'd expect to be born under each sign. All right, let me bring up Excel. It'd be equal to 1067 divided by 12. It should be 88.9 for each group, because they'd all be equal, because you'd assume that it's an even distribution. All right, I'll meet you back here next time. This is what I'm going to fill in between videos.